shifted them up, down, left, right, and you also did what to it? Yeah, you could have flipped them like reflection. You stretch them or flatten them, yeah. Okay, so we're going to expand upon that in grade 12 pre-cal. And not only are they going to be stretched vertically, we're also going to be stretching horizontally. That's the addition of it. So there's many ways we can transform functions and relations. Last year or last semester, we did transformation of quadratics or parabolas, which we shifted up, down, left, right. We also did vertical stretch, meaning we went narrow or wide. Okay, so these are the graphs you have to know, like hands down, what they look like. So can anybody tell me what a linear graph looks like? Y equals X. It's a line that is how? Like, describe it better. Diagonal, sure. So I guess an important thing is it's going through 0, 0, right? And it has a slope of 1. And that's what makes that vertical line here. Remember y equals mx plus b? Yes? So y-intercept is your b, and it's going, there is no y-intercept in y equals x, so the b is 0. That's why it's going through 0, 0. And then the slope, if you don't see a number, that means it's 1, right? Okay, how do you do a quadratic, the base quadratic? Yeah, it goes through 0, 0. Yes, so make sure you know that pattern 0, 0, 1, 1, 2, 4, and if you have to go even bigger, 3, 9. And then mirror it. So 0, 0, 1, 1, 2, 4, and it's a mirror on that side, so then we get something that looks like this. Or 4, 16, yeah. And then, of course, we shifted them after that. Okay, who remembers what an absolute value graph looks like? Yeah, it's like a V. So basically, it's graph number 1, and anything that was underneath the x-axis got reflected up. So that part goes up, and you end up getting this V shape, right? At a diagonal 45. Okay, who remembers the rational function 1 over x? Nope. Yeah, the floops. You have a vertical asymptote at the y-axis, a horizontal asymptote at the x-axis. It goes through 1, 1, and negative 1, negative 1, and you have like a floopy looking thing going like this, right? Remember that? Yeah? Okay, so now translations. All we're doing now is we're taking those parent graphs with those, say, 3 points, and we're just going to move them. So translation is a transformation of a geometric figure. In this case, the geometric figure is a graph in which every point is moved the same distance. So who can tell me, if we have a parabola, a base parabola, y equals x squared, what happens if I were to graph y equals x squared minus 2 compared to the y equals x squared? It'll move down too. Very good. Now this should be fresh in your mind because you just took this, right? How about the next one? Y equals, in brackets, x minus 2 squared. Moves to the right 2. It's going inside the function, so it has a compensation effect where it's doing the opposite of what you think. Okay, how about the next one? How about this one? Left 4. Okay, next one. There's 2 things happening. What's happening? Yeah, right 2, up 1. Now, somebody said up 1, right 2. Is that okay? Yeah. Does it matter if you start here and you go right 2, up 1, or if you go up 1, right 2? Will you get the same spot? Yeah, it doesn't matter the order. X moves have nothing to do with the Y moves, okay? Going on. Okay, who can graph a base graph of y equals the absolute value of x? So remember that diagonal is going through 0, 0, 1, 1, 2, 2? And it's got that mirror. So this is our base graph. Does everybody see that? You should probably use a ruler just to make sure. It better have arrows or you're losing a half mark. So this is y equals absolute value of x. Now, who can tell me, this is a tricky one, What happens to that graph when I graph y equals the absolute value of x minus 1? I hear moving to the right one. Moves to the left one. Anybody else? Moves it up one. We're not quite sure. You're thinking it's going up one? So just to see, what's the difference between A and B here? When it's outside the absolute value. Does anybody want to change their answer now? Yeah, it's actually going to the right one. This is the same thing as the parabola over here, where it was inside the brackets. Inside, do you see, this is the squaring function of the parabola. The function gets squared. So do you see when we go back to this absolute value, the function is the absolute value. So if it's inside, it's affecting the input or your x. So as a result, it's going to go right one. So I'm going to change my color. So this point gets moved right one. This point gets moved right one. This point gets moved right one. And then you can just kind of connect the dots. And this is my A graph. Usually on a test or a quiz, we only have one graph per question. But on this case, I have actually 3 graphs. So I'm going to change colors here. Okay, how about B? Who wants to guess what happens there? It's outside the function, so what is it affecting? Yeah, it's going to go down 5. This was supposed to be right 1. I'll add that in there. So anyways, this is affecting the parent graph, not my green graph, the blue graph, the original graph. So I'm taking this blue graph, and I'm taking those points, and I'm moving down 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You can see what it looks like. It looks exactly the same, just down 5. There's my B. Are we doing okay? Okay, I'm going to go to black now, or maybe I'll make it purple, just for fun. Oh, maybe make it orange. Okay, so who can tell me what the C graph is doing? 2 things. Left 4, down 3, very good. Okay, so we're going to take this blue graph, and we're going to go left 4, 1, 2, 3, 4, down 3, 1, 2, 3. And we're going to do that to all 3, but because this is in stretch, it's pretty easy to see where it's going to go after that, right? You just make the V after that. Okay. Okay, so last semester, we went over piecewise functions. Do you remember what they were? We could actually say it like this. F of x equals a string of different functions in different domains. Does everybody see? For this graph here, it's comprised of how many functions? 3 functions. There's a function here, a function here, and a function here. Yes? Okay, let's see if we can come up with the name of this function. What's the name of this function right here? Anybody? Yeah, x plus 3. And it's x plus 3. Do you see it's got a slope of 1 going through 3? It's valid between what and what? Yeah, -3 and 0. And the way we write this, we put -3 is less than x is less than 0. Yeah? X is between -3 and 0. Okay, but because it's filled in right there, we need to put a little equal sign there. And it's filled in there, so we're going to put an equal sign there. Okay, what's the next function, this flat one? Y equals 3, very good. And that's valid between what domain? 0 and 2. So I'm going to go comma, 0 is less than or 2. This time I'm not going to put equals because they can't equal 2 different functions at the same time. So you either make a decision and make it equal to 0 here or equal to 0 here. Technically I could make it equal to 2 there as well because it's filled in right there. But let's keep going. What's the name of this function here? This one's a harder one. Maybe extend it so you can see where it intersects the y-axis. Yeah. So what's the equation? X plus 1. And that is valid where? 2 and bigger, right? Because it has an arrow. So how do I write that? X is greater than or equal to 2. Okay, so we're going to go into more depth of piecewise functions a little later. For this type of question, you wouldn't be asked to come up with this, but it's good practice. Okay, so this is the f of x function. So they'll give you some made-up function here, and they want you to graph g of x. And they said g of x is f of x plus 3. Can anybody guess what's going on to the f of x graph in order to graph g of x? I hear up 3. Anybody else want to take a guess? It's inside the function. Right 3, I hear? It's left 3, actually. It's just like the parabola in the fact that everything just gets, like when it's inside the function, it's counterintuitive like that. Okay, so we're going to go left 3. 1, 2, 3. Where you should be doing this is anywhere that it turns direction. So you don't need to necessarily take any points here, but you could take a point here. This 0, 3, if I go left 3, 1, 2, 3, there's the other point, and then we're going to connect it like that. This point right here, we're going to go left 3, 1, 2, 3, and then we're going to connect it. Do you see? And then just to see where it's going, maybe take this point, go left 3. There you go. There's the rest of your graph. So there is my A. Okay. I'll give you a second. Okay, so how about B? It says h of x plus 1 equals f of x plus 2. Does anybody think they know what happened there? I hear left 2, and then what? Ooh, down 1. I thought I'd trick you there. Yes, and if you don't realize it's down 1, if you look to this one, do you see if I move the 1 over to the other side, it's a minus 1? So does it make sense now? We're going left 2, down 1. Okay, so sometimes, and I'm calling this table of values very loose. Sometimes we get quite complicated, and a table of values is nice to have. What we do is we do what's called mapping notation. So we have some arbitrary x and y. If we take some x and we go left 2, down 1, where would the x be now? Okay, so if you don't know, let's try negative 3, 0. Where would negative 3 be if I go left 2, down 1? It would be negative 5. Well, we could do the 0. Where would the 0 be? Negative 1. So everybody can see it with numbers. Now let's go back to the mapping notation. If I start at x and I'm going left 2, down 1, where would x be? Okay, let's do another one here. Okay, if I'm at 0, 3 and I'm going left 2, down 1, where would the 0 go to? Okay, how come you can get it so easily there? If I start at x, what am I doing to it? I'm subtracting 2. So what would my new x be? X minus 2, yeah. There you go. If I'm starting at some y and I'm going down 1, what would my new y be? Y minus 1. Okay, so where I'm going with this is we're eventually going to do 5 or 6 transformations. So sometimes it's really hard to keep track of stuff. Like when you're just going left 2, down 1, that's pretty easy. You could just take this and go left 2, down 1 and redraw it. But when we have 5 things going on, sometimes it's easier to do, and again, I call it a table of values. It's not really a table of values. I'm taking certain points where they change directions, coming up with the rule, and then coming up with a new point. So 3, if I go down 1, I'll be at 2, right? 2, if I go left 2, I'll be at 0. 3, if I go down 1, I'll be at 2. 3, if I go left 2, I'll be at, 1, and 4, if I go down 1, I'll be at 3. So then what I do with this is then I can just plot it. So do you see how if I take my beginning graph, the black graph, and if I go left 2, down 1, do you see I'm actually at -5, -1? And then if I just connect it to -2, 2, you see? I could just plot it this way. 0, 2, there you go. 1, 3, 1, 3, and then there's the rest of my graph. Do you see that? It's just another way of doing this. If you like coming up with specific points and doing it, or just taking your pencil and saying, I'm taking this point at -3, 0 and going left 2, down 1, plot the point. Again, it's really easy when you're only doing 2 things. When you're doing 5 things, you might lose track of stuff. So that's why I show you the mapping notation. Okay, so now here's 2 graphs. One's f of x, one's g of x. And it's saying you need to come up with what happened here. So we're starting with f of x, and it's becoming g of x. So first off, if I start with, say this is the point 1, what would be the corresponding point in the g of x graph? Yes, -4, 5. And because there's only, you could see visually, this thing didn't get stretched at all. It just got shifted left and then up. So our first guess is it went from 1 to -4. It must have went left how much? 5. And it went from 3 to 5. It must have went up 2. So I'm going to do a couple more points just to make sure. So we'll do these 2. So this one's at 4, 2. Oh, sorry. Hello, let's do the one that's next on here. Let's do this one and this one. 4, 2 becomes -1, 4. Yes? And 6, 5 becomes 1, 7. And 8, 5 becomes 3, 7. And 9, 4 becomes 4, 6. Yes. Okay, so can everybody agree in all the points they went left 5? Yes? And it went, the vertical translation, it went up 2. Okay, so if this is the form for what happened, how would I write f of x going to left 5 up 2? So left 5 has to be inside the function because it's affecting the input. So it's going to be x plus 5. And then up 2 plus 2. Now, notice their form, they want it like this. So what's different about what I just wrote and what they want? I'm sorry? Yeah, I just need to move the 2 over to the other side. So y minus 2 equals f of x plus 5. You just got to watch the question, how they want the form. You make sure you put it into that form they want. If they don't specify any answer is sufficient. But if they actually specify a certain form, you need to make sure you have it that way. Okay, so now if we look at the summary of what we went over today, which really was just a review, right? In a disguise. If we have K, what kind of translation is that? I guess the word I'm looking for, is it horizontal or vertical? It's a vertical translation. And that affects, by the way, vertical is C-A-L. And that affects your X or your Y? Your Y. Okay, so look at the form that this is. The K is on the left side with a minus. So it's saying here, if K is greater than 0, so say 5, 6, 7, something like that, positive, right? How would it move it? it would go up that many units. And if k was negative, like -2, -1, look, when I put it in here, do you see this is going to be y plus 1 or y plus 2 because negative, negative? But then when I put it over to the other side, it'll still be a minus k. It's not really a minus k, it's a subtracting of whatever the k value is. If k is negative, is it going to go up or down? It's going to go down. Okay, so same with this. This form has the subtract h, which that's why when we have, say, f of x plus 3, really this is f of x subtract -3. Do you see that? Because the form has the subtraction. So when I have a negative, it's actually going to the left. But when it's simplified, it says plus, and so that's why a lot of people want to say it's going to the right 3, but it's actually going to the left 3 because it's a -3. Do you see that? Okay, so this is a horizontal translation, and it affects the x. If x is greater than 0, meaning it's positive, like say 5, 6, 7, 8, whatever, the graph moves which way? It's positive. It's going right or left? It's going right. Now, again, I'll explain. If h is positive, so if h is, say, positive 5, do you see it'll still be x minus 5 because the subtraction is part of the form? That's why it's going right. Okay, if it's minus something like this, do you see in the form that subtraction becomes a plus when we simplify? But really, it's still going left. This might be a little confusing just because of the sign change, but anyways, that's all I got there.